Today in this video, I will share some basic NAT types using a Mikrotik router that is very useful in actual scenarios wherein traffic optimization and manipulation is needed. In the diagram, I used a Mikrotik router connected to two ISPs. Each ISP provided me an IP address that is masked to their respective public IP address. Here, we will configure NAT based on the source and destination IP addresses. For the network details, WAN 1 is connected physically to Ethernet 2 with an IP address of 192.168.7.214/24. WAN 2 is connected to Ether 3 with an IP address of 192.168.18.14/24. For the LAN side, LAN 1 is assigned an IP address of 192.168.2.0/24. LAN 2 is assigned an IP address of 192.168.3.0/24. Let us start with the configuration. First task is basic configuration, including IP address configuration, port tagging, routing, DHCP configuration, NAT configuration, and actual testing. Open the Mikrotik router in Winbox. Create two bridges for LAN 1 and LAN 2. Next, configure IP address for each WAN and LAN interfaces. For WAN 1, input the IP address, then tag to port Ethernet 2. For WAN 2, tag the IP address to port Ethernet 3. For the LAN side, configure the IP address of LAN 1 and LAN 2 and tag to their respective bridges. Next, create two default static route using the gateway IP provided by each ISP. For WAN 1, the gateway is 192.168.7.1. Enable the check gateway to ping, then set the distance to 1. For WAN 2, set the gateway to 192.168.18.1. The same setup with WAN 1. In the route list, we can see that by default, the primary path is via WAN 1, which is in color black. WAN 2 is the secondary path in color blue. Before we continue, let us check if both the WAN IP addresses can connect to the Internet. To test, open Tools, then choose Ping. Disable the WAN interfaces one by one and see if the connection to Internet is not interrupted. We can see that from the router, connectivity is not interrupted if either of the links fail. The failover setup is working. We can now proceed to the next step, which is to configure DHCP for both the LAN interfaces. Click IP, then DHCP. Click DHCP Setup, then choose the server interface to bind. Click Next, then set up the DHCP address details, including the network, gateway, address range, DNS server, and least time. Repeat the process for the other DHCP server interfaces. Next, enable NAT for both the LAN interfaces to be able to connect to the Internet. Click IP, then Firewall. Under Firewall, go to NAT, then add New Instance or NAT Rule. On the Action tab, choose Masquerade. Click General tab, then choose the chain as Source NAT. Then input the source address for LAN 1. Repeat the process for LAN 2. Let us check on the router if both the LAN interfaces can connect to the Internet. Use Google IP as the destination IP, then the LAN IP address as the source IP. Conduct ping test per interface. Both LAN 1 and LAN 2 can connect to the Internet successfully. We can now proceed with the actual testing on the laptop. Go to Bridge, then click Ports. Add new bridge port. First, bind port Ethernet 4 to bridge LAN 1. Now, connect Ethernet 4 to the LAN port of the laptop. Then, set the network settings to DHCP mode. Open a browser and verify the public IP address. The laptop can now connect to the Internet using LAN 1's network masked to WAN 1's public IP address, since it is the primary path. Next, bind port Ethernet 4 to bridge LAN 2. Go back to the laptop, then verify the IP address details and Internet connectivity. As we can see, the LAN IP address comes from LAN 2's network. The WAN IP address is the same for now. On the router, go to IP, then DHCP server to verify the leased IP addresses. Both LAN DHCP server interfaces successfully leased an IP address to the laptop with Internet connection. Now, let us test the failover. Shut the WAN interfaces one by one to verify the Internet connectivity and public IP address. Upon shutting down the primary WAN interface, which is Ethernet 2, the connection was interrupted, but in milliseconds only, since the traffic transfers to the second WAN interface, which is Ethernet 3, immediately. The same result when the secondary WAN interface fails. When Ethernet 3 is down, the public IP address matches with ISP1. While the public IP address matches with ISP2 when Ethernet 2 fails. In the next part of this series for Mikrotik NAT types, I will share how to configure basic mangle rule and routing mark to force or manipulate the traffic to a specific ISP or WAN. I hope that this is informative to you and thank you for watching.